Welcome to another comprehensive tutorial on traditional project management approaches brought to you by freestudies.in. Traditional project management approaches have been the backbone of many successful projects across various industries. Among these approaches, the waterfall and sequential models stand out as time-tested methods that have proven their effectiveness. In this tutorial, we'll delve into traditional project management methods, focusing on understanding the waterfall methodology and its core components. The waterfall project management approach is a linear and sequential method that divides a project into distinct phases. Phase structure. The waterfall approach divides projects into clear and distinct phases, each with its own purpose and objectives. Requirements. The initial phase where project stakeholders collaborate to gather and document detailed project requirements. This phase establishes the foundation for the entire project by defining what needs to be achieved. Design. Following the requirements phase, the project moves into the design phase. Here, teams draft detailed plans and blueprints outlining project development, including technical specs and architectural designs. Development. Once the design phase is complete, development begins. This phase translates design into a functioning product through coding, construction, and programming. Testing. After development, the project progresses to the testing phase. Deployment. With successful testing and approval, the project moves to the deployment phase, where the final product is released to end users or customers. Maintenance. The final phase, maintenance, involves ongoing support, updates, and enhancements to ensure the project's continued functionality and relevance. Sequential progression. In the waterfall approach, the progression of the project is strictly linear. This means that each phase must be completed before the next one begins. Clear documentation. The waterfall approach places a strong emphasis on documentation at every phase of the project. Detailed documents are created to define project requirements, design specifications, and testing criteria. These documents serve as a reference point throughout the project's lifecycle, providing a clear and documented trail of decisions, actions, and outcomes. Well-defined requirements. One of the fundamental principles of the waterfall approach is the establishment of well-defined project requirements at the beginning of the project. Well-defined requirements provide a clear roadmap for the project, reducing the likelihood of misunderstandings or scope changes during later phases. Longer delivery times. The waterfall approach is known for having longer project delivery times compared to more agile methods. This is because each phase must be completed before moving on to the next, and changes or revisions can be challenging once a phase is finished. While this structured approach can ensure a thorough and methodical project execution, it may not be suitable for projects in fast-changing environments or industries where rapid adaptation is essential. Understanding these characteristics of the waterfall approach is crucial for project managers and teams to determine whether it is the most appropriate method for a particular project. It excels in scenarios where project requirements are stable and well-defined, and changes are less likely to occur. The waterfall methodology follows a strict set of phases and processes. Each phase builds on the previous one, making it crucial to complete each step before moving on. The key phases in the waterfall methodology include requirements. In the requirements phase, project managers, stakeholders, and the project team collaborate to gather, analyze, and document project requirements in meticulous detail. This phase is the foundation of the entire project, and it is essential to have a clear understanding of what the project aims to achieve. Stakeholder collaboration. Engaging with all relevant stakeholders to identify their needs and expectations. Regular communication ensures everyone's concerns and requirements are understood and addressed. Requirement gathering. Collecting information on functional and non-functional requirements. This includes interviews, surveys, and workshops to ensure all necessary features and constraints are documented. Requirement analysis. Analyzing and prioritizing requirements to ensure they are feasible and aligned with the project's goals. This involves evaluating relevance and impact to create a clear and actionable set of requirements. Documentation. Creating comprehensive requirement documents that serve as a reference point throughout the project. The requirements phase aims to leave no room for ambiguity and ensure that all project stakeholders have a shared understanding of the project's objectives. Design. Once the project requirements are well defined, the project moves into the design phase. This phase involves creating a detailed blueprint of the project, outlining how it will be built and what it will look like. Key activities in the design phase include architectural planning, defining the project's architectural structure and components, technical specifications, determining the technical requirements and specifications for the project, user interface design, creating user-friendly and aesthetically pleasing designs for products or software interfaces, prototyping, building prototypes or mock-ups to visualize the final product's appearance and functionality. The design phase serves as a bridge between the conceptual understanding of the project's requirements and the practical implementation that occurs in the subsequent phases. Development. During the development phase, the actual project is constructed according to the design specifications developed in the previous phase. Coding. Writing the actual code for software applications or creating physical products. This involves translating design and requirements into executable programs or functional items. Unit testing. Testing individual components or units of the project to ensure they function as intended. This process helps identify and fix bugs at an early stage. Integration. Combining various components into a cohesive whole. This step ensures that all parts work together seamlessly within the complete system. System testing. Evaluating the entire system to identify and resolve any issues. The development phase transforms the project's design into a tangible and functional product, adhering to the predefined requirements and design specifications. Testing. The testing phase is a critical step in the waterfall approach, where the project is thoroughly evaluated to identify and rectify any defects, errors, or inconsistencies. Key activities in the testing phase include testing scenarios, creating test scenarios and cases based on project requirements. This involves devising specific situations to evaluate the system's performance and functionality. Functional testing, ensuring that the project functions as expected in various scenarios. This process validates that the software or product meets the specified requirements and performs its intended functions correctly. Regression testing, retesting to confirm that previous issues have been resolved without introducing new problems. This ensures that changes or fixes made to the project do not adversely affect previously working functionalities. User acceptance testing, allowing end users or stakeholders to validate that the project meets their expectations. The testing phase ensures that the project is free from critical defects and is ready for deployment to end users or customers. Deployment. After successful testing and approval, the project advances to the deployment phase. In this phase, the project is made accessible to end users or customers. Key activities in the deployment phase include installation, implementing the new website, ensuring it is correctly installed in the intended hosting environment. This involves setting up the necessary files and components to enable the project to run smoothly. Configuration. Configuring the project to work in the target environment. This includes adjusting settings and parameters to ensure compatibility and optimal performance within the intended deployment environment. Training. Providing training to end users or customers on how to use the project effectively. The deployment phase represents the culmination of the project, where it becomes available for its intended audience. Maintenance. The final phase, maintenance, involves ongoing support, updates, and improvements to ensure the project continues to function optimally. Key activities in the maintenance phase include bug fixes, addressing and resolving any issues or defects that may arise after deployment. This involves identifying and rectifying errors to maintain the project's functionality and reliability. Updates. Providing updates to the project to enhance its functionality or security. This includes implementing new features, improvements, and patches to address emerging needs or vulnerabilities. User support. Offering ongoing support and assistance to end users. This involves helping users troubleshoot issues, answering queries, and providing guidance to ensure a positive user experience. Performance optimization. Continuously monitoring and improving the project's performance. The maintenance phase ensures that the project remains reliable and effective throughout its life cycle. In contrast to the waterfall approach, Agile project management is an iterative and flexible method that focuses on collaboration, adaptability, and customer feedback. Agile allows for changes and adjustments throughout the project, making it well-suited for dynamic and evolving environments. For further resources and free tutorials on project management and related topics, visit freestudies.in, a platform that offers educational materials and resources to enhance your knowledge in various subjects.